All right, guys. Sorry, I thought I had this going. There we go. Again, happy Tuesday. Hope you did great on your 6.2 test, which is the properties of matter. We're going to continue with items about matter for the next 3 or 4 weeks. If you didn't do as well as you want, we will discuss retakes in class, so don't freak out. We'll go from there. Hopefully, then you took the pretest over this lesson. It will not count in your grades. I just want to see what you guys know, and so that I can get you on your learning paths for this lesson. All right, let me get my face out of the way there. All right, so this lesson has one essential question, and it is, how are atoms and elements related? And maybe you don't know what either one of those words means right now, but you will. And by the end of the time we're finished with this lesson, you'll be able to describe atoms and elements, how they're related, their properties, and so on. All right. You will be able, in about a week or 10 days, to describe the ways atoms make up matter, how that works. You will be able to describe the particles that make up atoms and how they're used to identify all the elements. You're going to learn several new words, what they mean, and how they apply to all of this. You will describe what a chemical symbol is. If you've ever seen the periodic table, you might know what I'm talking about. If not, it'll be a whole new experience for you. And lastly, this periodic table that I just mentioned, there's like 3 sections or 3 parts, 3 categories, I guess would be the best word: metals, nonmetals, and metalloids. And you'll be able to explain how their properties are different. That's actually a question on the pre-assessment. So I'm anxious to see if anybody got that. All right. Again, just as last lesson, we're addressing this standard. All matter is made up of small particles called atoms. And then there is the standard that you use appropriate math tools and techniques for information, and that you know how to analyze and interpret data. All right. Each lesson in our book, and we will be getting more into the actual book starting next week when you hybrid kids are all back together. We'll look at that. And you at-home kids, I will make sure I have videos or a Zoom or whatever we need to do to make sure you're okay with how to access all the reading in the textbook. Anyhow, let's look at these questions. Atoms are smaller than electrons. Again, 2 words that might not mean anything to you, but they will shortly. Well, you might want to guess at this, but an electron is part of an atom, so therefore electrons are much smaller than atoms. Next question. Single atoms can be seen with a powerful light microscope, a basic microscope. Nope, no way, And lastly, there are more than 100 elements on the periodic table. Give it a good guess in your brain, in your head, and that is true. All right. So the inference question for this lesson: why do the 2 elements, silver and iron, have different properties? Okay. Again, these are elements, and we'll learn what that is. Silver and iron, why are their properties slightly different? Okay, well, they're made up of different atoms. And we will get into all of that as we go through this beginning lesson, and then as we go further into the details of this. Not going to worry about this, but I do want to look at the vocabulary terms. We haven't really done like actual vocabulary yet in science, but we are going to, because these words are so important in knowing their meanings. So probably Wednesday or Thursday, probably Thursday, this will be one of our assignments, and I'll go through how I want you to do the vocabulary. I know every teacher is different, but how I want you to do it. All right, here we go. What are atoms? So all matter in the universe is made up of very teeny small particles called atoms. Okay, and here would be what I would call the definition. They're the basic building blocks of matter. Think of like the bricks that build the middle school or make up the middle school. Okay, the basic building blocks, how matter is built. I know that's redundant, sorry. Because they are the smallest particles that can have the same properties as the matter they make up. So they are alike everything that they are with. All right. Different atoms can be combined in different ratios to form all the substances we encounter every day. And we will go through those, not as much in this lesson, but next lesson for sure when we get into different, we take the next step up. All right. Very important item right here. There are 3 parts of the atom, essentially. They kind of combine to form a couple more, but all right. All atoms are made up of subatomic particles, subatomic meaning smaller than an atom, that have different electrical charges. Okay, we're going to start with what's called a proton. Think of P for positive. Okay, and they are found in the nucleus, and they have a positive charge. The nucleus is the center of the atom. Everything happens in the center with everything around it. Okay, the other particle found in the nucleus is a thing called a neutron. And if you look, any of you neutral, not going either way, okay, that is what a neutron is. It is in the center of the atom in the nucleus with the protons. Okay, and they make up the mass of the atom. So when we get to that term and that idea, that concept, keep that in mind, that the protons and the neutrons make up the mass in the nucleus. All right, the last thing in the atom are the electrons, and they're the smallest, subatomic again in the atom, and they are found outside the nucleus. In the area they call it is an electron cloud. It's just kind of a cloud that floats around. We'll look at that in a second. And they are negatively charged. Negatively charged. Ooh, my light went out, because you're just going to have to deal with seeing me in the dark. All right. Atoms are electrically neutral overall because they have the same number of protons as electrons. So that means they're neutral. So if it's 9 protons, they're going to have 9 electrons. All right. This is a carbon atom, and I know that because it says carbon atom, but I also would know it because it has 6 neutrons and 6 protons. So I don't especially like this diagram because they don't show you all the protons, but you have to assume there's 6 in there and 6 neutrons, and then you have the 6 electrons along the outside. All right, so this is a basic model of an atom, and you're probably going to have to do a drag and drop with this in a couple days. But let's look at the parts. They've identified the protons for us. What is with the protons in this center part? Does anybody remember? All right. Oops. Well, never mind. We're going to do the outside first. First of all, I lost my extra light, and now I'm clicking the wrong button. Anyhow, the outside of the atom are the electrons, and they float in the electron cloud. Okay. In the center of the atom are the neutrons. And together with the protons, they form the nucleus. Okay? So it's kind of mandatory we learn this stuff. This is kind of the basic, the 2 + 2 of the math world. Okay? All right. Now we're going to look at the thing called an element. And it is a pure substance, meaning it's only made of one thing. Okay, so there's not hydrogen and oxygen in it. If we're talking about hydrogen, there's just hydrogen. That is an element. It is made up of only one type of atom. Okay. This says there's 118 elements. I have seen a different number, but about that. And 98 of them occur naturally, meaning found in nature. The rest are what's called synthetic, and we'll get into that as we get further into the lesson. All right. And again, an atom is the smallest unit of an element that has the properties of that element. Okay. They're the same throughout. All right. How do we describe the elements? Well, they are identified by their atomic number and their chemical symbol. And you're probably like, what is that gibberish? Well, I'm going to tell you what it is right now. All elements have a different number of proteins in the nucleus, nuclei, as they say here, which means more than one nucleus. So we identify them based on their proton number. And that is called the atomic number. The atomic number of an element is the number of protons in the nucleus. We're going to look at an example here right now. For example, the atomic number of aluminum is 13, so it has 13 protons and 13 electrons because those stay equal so that it has no positive or negative charge that balances out. Okay. The number of neutrons can vary. In this example of aluminum, it says generally it has 14 neutrons. And they tell you that because of what's going to happen next. All right. You will be doing this in a few days. I will give you an element, and with the help of the periodic table, we will look at how we could draw the model. Okay. So it wants us to use aluminum like we had on the last slide. So think back, how many protons do we need? 13. So that means 13 electrons. But remember, it did say there are 14 neutrons. So in this drawing that this student completed, let me pull this up here. Oh, I guess it wasn't missing anything. They did a nice job of labeling. Okay, so in the blue are the protons, and I'm not going to bother to count, but I'm going to trust that there are 13. Again, they've made 14 neutrons, no charge, positive charge, and then 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 electrons. Okay, so again, we will practice with those in the next few days. This will be on the announcements as well, but make sure now you go to IXL F5. It's about chemical and physical properties. And again, if you didn't do well on your test, no need to freak out. We will, I will give you some review options, and then you can retake it in the next day or so. All right. This is kind of some cool stuff. Just be patient as we lay the groundwork and head on through the lesson. All right. Take care.